Hi, this is Tom Dick. I'm a mathematics professor and a math advisor for Texas Instruments. This short video is part of the TI in Focus AP Calculus series. We're going to be taking a look at how you can check the solutions you get for differential equations by using the graphing capabilities of your TI-84. Let's get started. We're going to use as an illustration the differential equation that appeared in the 2019 AB and BC free response question number 4. This had to do with a barrel of rainwater, and the differential equation was dH dt equals -1/10 times square root of h, with an initial condition that the h value was 5 when time t equals 0. This was on the non-calculator part of the exam, so it was certainly intended to be solved by hand using separation of variables. So we're assuming that you've solved such a differential equation by hand, but now you're wanting to get some kind of check on your answer, and we want to show you how you can use the TI-84 to do that. So what we've done here is we've gone to the y equals menu, and you can see that in y1 we have a solution that we've come up with, and this is actually the correct solution if you do separation by variables. Now, to check this solution visually, we've set up two other functions, y2 and y3. What these represent are the two sides of the differential equation. y2 is basically our dH dt. Notice we've had to use y1 to stand for h, and x we're using in place of t because that's our independent variable for function plotting. Now y3 represents the right-hand side of the differential equation. Notice -1/10 times the square root of our h function. Now I'm going to set up the window for graphing here. I'm going to make this fit the physical situation a little bit more accurately. So x-min is our initial time of 0. I'll set the x-max time to be 30, x-scale of 5, and let's make our y-min -1, y-max 5. Now I think we're ready to graph and see what we get. Now we've got three curves here. I want to make sure we keep these straight. These two curves down here are really important to us. So they're the two sides of that differential equation. I'll turn on the trace so we can see which ones are which. The blue curve is our solution curve. y2, the red curve, is the derivative of that solution curve, and y3 is the -1/10 times the square root of the solution curve. So dH dt is supposed to be equal to that -1/10 square root of h, and we can see that they're lying right on top of each other. So these two graphs are providing strong numerical and visual evidence for us that our solution curve appears to fit the differential equation. Well, that ends this short video. For more resources like these, please see education.ti.com.